Hello everyone. Have you ever come across the term LCOE or levelized cost of energy? Have you ever wondered what it stands for, how it's calculated and why it's useful? In this video we'll explore these questions in more details. Great, so let's dive right in and look into LCOE and levelized cost of energy for solar plants. So what is LCOE? LCOE is the net present cost of electricity generation for a generating plant over its lifetime. That basically means effectively what is the cost per kilowatt hour over the lifetime of the plant in today's terms. Great, so the cost will include your initial investment cost, any O&M cost, operation maintenance cost, replacement cost and insurance cost over the life of the project. It will also include any fuel cost in the case of non-renewable sources such as gas, coal or diesel. So why is LCOE a useful metric? LCOE is a useful metric because it can be used to compare different electricity generation technologies on a level basis with each other. For example, solar, wind, hydro, coal, nuclear, gas or diesel. One can also compare the current rate you are paying for electricity with what it will cost if that electricity is generated from solar power. So if you look at LCOE in more detail for a solar plant, it will look as follows. Your total expenses will consist of your initial cost, also called your capital expenses or CapEx for short, plus your operating expenses such as maintenance. Then calculate the total energy produced for the lifetime of the plant. For a solar system that would be 25 years. Divide the two figures with each other to get a cost per megawatt hour or kilowatt hour. Before we go into details of how LCOE is calculated, let us go through a few definitions and descriptions. Solar panel degradation and discount rate. Firstly, degradation. All solar panel loses a percentage of its output power per year. This is called solar panel degradation. It is important to take this into consideration when calculating the amount of energy that will be produced or can be produced over 25 years. If you have a look at a solar panel data sheet, for example, this Canadian Solar IQ7 Mono PERC solar module, you can see here at the bottom subsequent annual power degradation of no more than 0.55%. So about 0.5% of power loss it will have per year. Also the first year you'll have about 2%. That is just due to light-induced degradation, and all solar panels loses a lot more power in the first year than subsequent years. Here they also mention LCOE, where they say when you use this panel you'll have a 3.5% lower LCOE. Just to clarify the term discount rate. The discount rate is the interest rate you need to earn on a given amount of money today to end up with a certain amount of money in future. So in other words, if you know you will get $1,000 in 10 years, how much do you need to invest today and at which rate, interest rate? The discount rate basically accounts for the time value of money, as $100 in 10 years is not the same as $100 today. It doesn't have the same value. 10% is a typical value used when calculating LCOE for a solar plant. Okay, so let's have a look at all the variables that you have to take into consideration to calculate the LCOE for a solar plant. Let's go through all these variables one by one. Firstly, your plant size in kilowatt peak, in this case a 50.5 kilowatt peak system. Then secondly, your capital expenditure or CapEx, in this case $38,391,000. Then your yield, what is your expected energy yield in the first year? So how many kilowatt hours per kilowatt peak installed per annum. Then your OPEX or operating expenses, what percentage or what amount of maintenance do you want to perform per year or expect to perform per year for the system or make provision for. Then typically your inverters will need replacement. We said here in year 12 we expect to replace the inverters we account for, so at least there's the costing for that involved, and the cost will be about $8 per watt peak installed. Then your degradation, as explained earlier, what's your loss of power for the solar modules per year. Discount rate, also previously explained. The future value of money, and also energy, as energy can be converted to rands and cents or to money. Your energy value also needs to be discounted. Then your escalation rate, your inflation rate, and lastly the period, in this case 20 years. You can also make it 25 years, which is actually a bit more typical. Okay, if you type all these variables into our spreadsheet, it will calculate all the values over 20 years. So how much energy generation is expected each year, how much operational expenses is expected each year, and in year 12 we account for inverter replacement costs of $8,076. Also, for a system that includes batteries, battery replacement cost will also be needed to take into consideration. This gives us total for energy production, total operating expenses, and total replacement costs. Then we take this total capex, opex, and replacement cost, add them all together, and divide it by the total energy produced over the 20 years. This then gives us a cost per kilowatt hour. In this case, $0.108 per kilowatt peak, or in other words, 10.8 cents per kilowatt peak. Okay, now that we have a better grasp on LCOE, let's have a look at a few graphs and examples. According to this report by Arena, the LCOE cost per kilowatt hour in 2010 was 37 USD cents. In 2018 it came down to 8 USD cents. This is a reduction of 77% in just 8 years. This is a massive reduction and one of the main reasons why solar has grown so much. These prices are being offered at commercial industrial level and in mature markets. Okay, so how does LCOE of solar compare to other technologies? Well, the good news is that solar power is currently the cheapest way of generating electricity. Many of us might assume that the reason so much energy still comes from gas and coal power plants is simple economics. Those fuels are cheaper. But though it was once true, that assumption has actually been proven false by a recent decline in solar and wind costs over the past decade. When it comes to the cost of energy from new power plants, onshore wind and solar are now the cheaper sources, costing less than gas, geothermal, coal and nuclear. In particular, solar in particular has cheapened at a blistering rate. Just 10 years ago it was the most expensive option for building new energy generation. Since then, that cost has dropped by 90%, according to data from the Levelized Cost of Energy report and as highlighted recently in Our World of Data. Utilities scale solar arrays are now the least costly option to generate electricity. Here is an interesting graph by Bloomberg and the World Bank. It shows the tariffs that commercial customers pay for electricity in sub-Saharan Africa. LCOE cost of solar power is between 8 and 15 cents per kilowatt hour. So one can see in which countries the LCOE cost of solar is the same or cheaper than grid electricity. This is called grid parity, when the cost of solar is the same or cheaper than grid electricity. At this point, it makes more economic sense to install solar rather than to keep on buying electricity from the national grid. It is also interesting to compare the 8 cents LCOE cost of solar with residential tariffs. Residential tariffs in 2022 in Germany were 37 cents, and in South Africa it was 17 cents. So a lot more than the 8 cents. It's also interesting to see what tariffs you are paying in your country. Would it be worth your while to install in the country where you are living? Maybe share with us by leaving a comment below.